In the last chapter, we have studied the wave in one dimension. We studied the mathematical property of the one-dimensional wave, and we discussed the property of the wave on the string. Okay. In this chapter, we will extend the idea of the wave to the sound wave, which is the propagation of the disturbance in the air. So in our case here, the air acts as the medium of the propagation. When we talk about sound wave, we can imagine the displacement of the air due to the disturbance of the source. However, sometimes it's more convenient to look at the sound wave as the pressure variation or the pressure wave that propagate through the air, because when there is a compression or refraction of the air, when the wave traveling through the air, the pressure of the air, the local pressure of the air change, and it has a wave pattern. So we can study the pressure wave, or we can look at the sound wave as a pressure wave. Next, one of the most important and interesting property of the sound wave is the speed of sound wave. And we will see that we can determine the speed of sound wave from the elastic property of the air, like when we determine the speed of the wave on the string from the tension and the linear density of the string, which is the related to the elasticity of the string. With the same manner, we can determine the speed of sound wave using the some linear property of the air, of the medium. Okay. Next, since we cannot see the sound, but we can hear the sound, one property that we are interested is the loudness of the sound. But in terms of physics, we call it the intensity, which is the energy that transferred by the sound wave per unit area, per unit time, and that will related to the loudness of the sound wave. And in the last section, we will discuss the Doppler effect, which we can observe this effect, like when we see the ambulance car move toward to us or move away to us, and if we notice the frequency of the siren, we may be noticed that the frequency of the siren change. It depends on the ambulance move toward to us or move away from us, and the change of the frequency can be explained by the Doppler effect. So that is the topic that we will discuss in this chapter.